Hey guys, Dr. Brown here again, and we're continuing. This is part 3 or part C of the finding volume by a revolution of a solid or revolution of an area. So we still have the same function or same 3 lines: y equals square root of x, y equals 0, and x equals 3. So the intersection of those 3 is the area that we're going to revolve, and this time we're going to revolve it around x equals 3. You know, in the previous 2 lessons we've revolved it around x, we've revolved around y, and now let's revolve around the line x equals 3. Now let's see, which one do you want to start with? Well, since I've already drawn in the differential in this direction, this is that rectangle that would be dy is perpendicular to the axis that we're rotating around. So that says I'm trying to use the disk method. Okay, and it says, let me make certain you can see what I'm writing. I think in the previous video I'm standing in front of it. Okay, volume equals pi times the integral from C to D of the major radius squared minus the minor radius squared, dy. Now this r of y, big R of y, little r of y, I've just left y subscript off to make it a little bit more clear. Okay, so the major radius would be the one farthest away from the axis that we're rotating around. So in that case, we have this distance right here, from here to here. That's what we're trying to understand. What is that distance? Well, this distance from 0 to here would be x. 3 minus x would give me that distance of the line right here. Well, since we're differentiating with respect to y, I need to say, well, what is x? X equals something. Well, x, if I square both sides, x equals y squared. So instead of 3 minus x, 3 minus y squared. So my volume is equal to pi times the integral from 0 when x is 3. If x is 3, square root of 3 equals y. So we're integrating from 0 to square root of 3 of this major radius, which was 3 minus y squared minus the minor radius. Well, notice that rectangle is sitting right on the axis that's getting rotated, so it's 0. So now I have 0 squared. Obviously that's 0, so there's nothing there. And we're integrating with respect to dy. Okay, so now let's square this guy. And that equals pi times the integral 0 square root of 3. So 3 minus y squared times 3 minus y squared. 3 times 3 is 9. Minus 3y squared minus 3y squared is minus 6y squared plus y to the 4th. dy. Okay. So let's integrate that. Integrating 9, a constant, now it's 9y, minus 6y cubed over 3, plus y to the 5th over 5, and all of that's from 0 to square root of 3. Okay, let's plug in some values here. Alright, it's 9 times square root of 3 minus 6 over 3 is 2. So 2 times square root of 3 cubed plus square root of 3 to the 5th over 5 minus, put in 0 for every one of those, 0, 0, 0, it's gone. All right, try to simplify this a little bit or multiply some things out. All right, square root of 3 times square root of 3 cubed is square root of 3 times square root of 3 times square root of 3. Square root of 3 times itself is 3, so this is 3 square root of 3 times 2, which would be 6 square root of 3. Get rid of that. Okay, now I've got square root of 3 to the 5th power. Well, I'm sorry for making this as simple as I can. That's 5 of them, right? So if I group a couple of them together, those two become 3, those two becomes 3, and that one's just left over. So 3 times 3 is 9, so this becomes 9 square root 3. So plus 9 square root 3 over 5. Now if I get a common denominator of 5, 9 times 5 is 45. 6 times 5 is 30. This is already over 5. Now then, what do we end up with here? Pi times 45 minus 30 is 15. 15 plus 9 is 24. So I have 24 square root 3 over 5 times pi. So now my volume equals 24 pi square root 3 over 5. Okay, so that was using the disk. 24 pi square root 3 over 5. All right, now then let's use the shell method on this same function. Rotate it around 3. Let me clean this up. All right, with the shell, you'll recall, it's telling us that we need to set up our differential rectangle parallel to the axis we're working around. And then we're trying to figure out what this distance is and then what this height is. This h of x and this is p of x. So the formula is volume equals 2 pi, the integral from a to b of p of x, h of x, dx. Okay. Same scenario here. I've got 3, if this is x, 3 minus x gives me that distance. So p of x, this is the integral from 0 to 3 of p of x, which is 3 minus x, times the height of this, which is just f of x, or y. So h of x equals square root x. And we'll go ahead and say that's x to the 1/2 dx. Now let's distribute that to the inside. 2 pi, the integral from 0 to 3, 3 times x to the 1/2 minus x to the first power, which is 2 over 2 in this case. X to the 2 over 2 plus 1 over 2 is x to the 3/2 dx. So now let's integrate. X to the 1/2 plus 1 is x to the 3/2 divided by 3/2, which means I'll multiply by 2/3. That will cancel. Minus x to the 3/2 plus 2 over 2 is x to the 5 halves multiplied by 2/5, and all of that from 0 to 3. So that equals 2 pi 2 times 3 cubed and then the square root. Now you know the rule here. A to the m raised to the n is a to the m times n. So we have that situation here. I have 3 raised 3 cubed, but it's to the 1/2 power. So I'm taking the square root of that number. 3 times 3 is 9 times 3. I'm just going to keep this 9 times 3. And I'll take the square root of that. That's 3 square root 3. So this number is 3 square root 3 times 2 is 6 square root 3 minus, make sure we did right here, 3, yep. All right, so minus 2/5 times 3 to the 5 halves. Okay, we're going to look at this a different way. We're going to look at this one as that's 3 to the 1/2 to the 5th power. So the square root of 3 raised to the 5th power. So 1, 2, 3, 4, 5. I have 5 of them. So these multiplied together gives me 3 times square root 3, and that's 9 square root 3. Alright, let's just keep that here. So 2 pi 6 square root 3 minus 2/5 times 9 square root 3. So 9 times 2 is 18 square root 3 over 5. All right, now 2 pi times, I got to get a common denominator here. So if I make a 5 on both, 6 times 5 is 30. 30 minus 18 is 12. So I have 12 square root 3 over 5 times 2 pi. So what does that give me? Yay, 24 pi square root 3 over 5. So that's my volume using the shell method. 24 pi square root 3 over 5. So both the shell and the disk provided us with that answer. So you can see either one of these seems simple enough, but for me, if I can keep it in a DX format, it seems to be we've worked so many problems that way it's easier for me to see. But there's times you need to be able to do the shell as well, shell or disk. So all right, why are we doing this? Like I said last time, together we're trying to build a better tomorrow and do that through math. Keep studying, guys. And the next video will be, we're going to rotate this same function about a line out here at x equals 6. So stay tuned. Talk to you later. Thanks.